Right now, off the coast of the Pacific Northwest, two massive slabs of the Earth's crust are locked together, pushing against each other, building up pressure that has nowhere to go. This isn't a hypothetical fault line somewhere far away. It's called the Cascadia Subduction Zone. It runs for about 1,000 kilometers from Northern California up into Canada, and scientists don't ask if it's going to rupture again, they ask when. So let's actually walk through it. What happens in the first 24 hours after the big one finally hits? First, some context because this isn't science fiction. The last time this fault ruptured was January 26, 1700. We know the exact date because the tsunami it triggered crossed the entire Pacific Ocean and was recorded by officials in Japan, thousands of miles away, who had no idea what had caused it until modern geologists connected the dots centuries later. Researchers studying underwater sediment layers have found evidence of at least 13 similar earthquakes at this same fault going back thousands of years, striking roughly every 300 to 500 years. Do the math, and the zone is sitting well within its overdue window right now. One recent study published in the Proceedings of the National Academy of Sciences put the odds at around 15% within the next 50 years, and closer to 30% by the year 2100. That's not a scare tactic. That's a probability scientists actually work with. So here's our zero. The fault finally slips, all at once, along its full length. And unlike a typical earthquake that jolts for a few seconds, this one keeps going. Seismologists studying similar subduction earthquakes like the 2011 Tohoku quake in Japan estimate the shaking here could last 4 to 6 full minutes. Try timing that on your phone right now. 4 minutes of the ground violently moving beneath you is long enough that people who have survived similar quakes describe losing the ability to even stand up, crawling instead, watching the world genuinely liquefy in front of them. In the first few seconds, something interesting happens that most people don't know exists. Earthquake early warning systems, like the real Shake Alert network already active on the U.S. West Coast, are built to detect the very first faster-moving seismic waves and send out an alert before the slower, more destructive waves arrive. In a quake this size, that could mean a warning of anywhere from a few seconds up to a couple of minutes for people farther from the epicenter. That's not enough time to evacuate a city, but it is enough time to stop a train, shut off a gas line, and get a kid under a school desk. In an event like this, those seconds are the difference between a broken window and a burst pipeline. Now the shaking stops. But hour zero isn't over because the ocean is just getting started. A rupture of this size doesn't just shake the ground, it displaces the seafloor itself, shoving an enormous wall of water toward the coast. Modeling by researchers at institutions like the University of Washington estimates the first tsunami waves could reach some coastal communities in under 20 minutes, some of them so close to the fault that the earthquake shaking itself is the only warning they'll ever get. There's no time for sirens in some towns. The evacuation plan is simply the ground shook, now run uphill. By hour one, the physical shaking has stopped, but the region has already changed permanently. Roads have buckled where the ground has liquefied. Bridges built before modern seismic codes may have partially or fully collapsed. Emergency planners who've studied this scenario for years, including researchers behind Oregon's official Cascadia Rising exercises, have modeled scenarios where major highways connecting the coast to inland cities are impassable for weeks, not hours. If you were on the coast when it hit, hour one might be the moment you realize the road out simply isn't there anymore. Hours 2 through 6 are when the invisible damage starts becoming visible. Power grids fail across a huge stretch of the region, not because of one broken line, but because the entire system loses stability at once. Water treatment plants, often built on the same soft, liquefaction-prone soil near rivers and coastlines, can go offline right when people need clean water most. Cell towers run on backup batteries that typically last a matter of hours, not days. So as the batteries drain, entire counties can go quiet at almost the same time, right as everyone is trying to reach their families. By hours 6 through 12, the story shifts from the earthquake itself to the response. FEMA's own planning documents for a Cascadia-scale event estimate a death toll in the thousands, with some full margin rupture scenarios reaching into the tens of thousands once you include the tsunami zones. But here's the part that surprises people. In this scenario, emergency planners assume it could take up to 2 weeks for significant outside aid to physically reach some of the hardest hit coastal areas, simply because the roads and bridges needed to bring in help are some of the same infrastructure the earthquake just destroyed. For the first days, in some towns, the people already there are the entire response team. By hour 12 to 24, exhaustion sets in on every level. Hospitals that are still standing are operating past capacity, often without reliable power or water. Search and rescue teams are working through the night using dogs and listening devices to find survivors trapped in collapsed structures, a race against time that specialists know gets dramatically harder after the first 24 to 48 hours. Meanwhile, aftershocks, sometimes strong enough to be significant earthquakes on their own, keep striking, collapsing already weakened buildings that survived the initial rupture but couldn't survive round two. So that's the first 24 hours. Not a single dramatic moment, but a chain reaction, 4 to 6 minutes of shaking, followed by hours of a region slowly discovering, system by system, road by road, exactly how much it just lost. Here's the part worth sitting with. This isn't a monster movie hypothetical. It's a documented historical, mathematically overdue event, sitting quietly off a coastline where millions of people live their ordinary lives every single day, genuinely unaware that a version of this countdown has already started. Somewhere out there right now, the pressure is still building. Nobody knows the exact day, just that, geologically speaking, it's already close.